All right, awesome. What's up? I'm Alex, the entrepreneur, setting up a new live in which we're going to go over Yearn version 2. If you have any question on the technology, on Solidity, React, Hardhat, Subgraph, etc., let me know. And I'll also give you some context as to why I'm doing the code review on Yearn today. And I have you in the chat here on the right. So the reason why I'm doing this is I share my screen. The reason why I'm doing this is I'm building a little tool that basically yield farms. And so I'm basically teaching myself this. So that's my goal. It's education purposes with the goal of building something for myself that I'll eventually share. That said, why would you want to learn from Yearn is very simple. When you start writing your own script, such as something that I wrote, you have perhaps a deposit function, a withdraw function, and then maybe you have something to invest. What's going to happen is you quickly realize that you basically built a monolith, which is, in my case, I built a monolith. And all of this code is tied to a specific way of yield farming. In this case, this is tied to Aave on Polygon. So I know you guys are out there out competing to ship this yield farming product. I'm checking on you guys. Between the way in which you do a deposit and the way in which you do the actual balancing, the harvesting, the farming, etc. And that means that this is great, as a solo investor. If I invest my own funds, this is great. It's going to automate all the process. It's going to give me all the stats. It's going to rebalance. It's going to do all that nice stuff. So it's great. However, if I want to build this into a product that other people can use, or I want to maintain this in a way where I can have different strategies, because in a couple of months, Aave and Polygon are no longer going to subsidize with Wmatic. So I basically need to build this with some extensibility in mind. And that's how the Yearn V2 was built, which is, I'm going to start zooming way deeper. I checked the previous video and I realized that it's really hard to see. So I'm going to actually zoom way more in this version. And if you remember, in the Yearn V1, we basically had 3 keywords. We had the vaults, controllers, and strategies. And in Yearn V2, we basically get rid of controllers and we only have vaults and strategies. So I'm in the Yearn vault repo, which is the repo for Yearn V2 or Yearn V2. I'm going to go in the contracts folder, and you'll see that we fundamentally have just a few set of Viper scripts, and then we have a couple of Solidity scripts. These are highly documented, so they're actually really well written. And so I'm going to be learning a lot as I go along, and you're going to be learning as well. Let's start by looking at the vault. Viper code for the vault, and blah blah blah. Vault open source. There's also an emergency shutdown. Let's actually read this over. Yearn token vault holds an underlying token and allow users to interact with the Yearn ecosystem for strategies connected to the vault. This basically gives you all the context, the architecture, etc., for what's going to happen. We expect to see strategies, which are going to be all the smart contracts that manage funds, while we're not going to be, and the vault is just a way to deposit that. Next up, we have, let's see, vaults are now limited to a single strategy. Yeah, they can have up to 20. Deposited funds are moved into the most impactful strategy that has not already reached its limit for assets under management. Regardless of which strategy a user funds end up in, they receive the portion of yields generated across all strategies. Okay, so that's great. And that means that there's going to be a generalization or a way to, let's say, more strategy as a portion of funds. There has to be a way to calculate which amount each strategy has and how that's going. When a user withdraws, if there are no funds sitting undeployed in the vault withdraw funds from strategies in the order of least impact, which means that funds are taken from the strategy that will disturb everyone's gains the least, then the next least, etc. So again, here, I'm expecting that there's going to be a way to estimate the yield that each strategy is going to give, and that's probably going to be weighted in with the amount of funds that are available in each strategy. So there has to be some sort of sorting way that makes withdrawal easy. And that's something that is actually really helpful, because in a naive way, when you're building your own strategy, you're probably gonna just unwrap and withdraw everything, because to actually do the math to not impact other people's funds is actually very sophisticated. In order to achieve this, the withdrawals queue order must be properly set and managed by the community through governance. Okay, so that actually defeats the, I guess we're going to use the hive mind of the governance instead of writing a script that does it. And so we'll see what actually happens. But yeah, this is actually a real challenge, is that you want withdrawals and deposits to be cheap. You want them to be easy to do, but you also want to be able to rebalance this vault and the strategies automatically. So you have to find a compromise. And I'm guessing the compromise here is using governance, because how will the strategy and the vault know which how much yield each strategy is projected to do? Which I believe could be done. It's probably an engineeristic challenge, and maybe this is going to be part of an improvement on Yearn or Yearn. Let's continue. Vault strategies are parameterized to pursue the highest risk-adjusted yield. So that means that there's going to be some sort of parameter that has to quantify risk, and then we're going to have to compare that with yield, because expected yield is something that you can always get. Let me give you the most basic example, would be Aave. And maybe there's like a few bucks on this developer wallet. But fundamentally, if you go on Aave, you'll see that you know exactly how much you can gain from each deposit and withdrawal and borrow. Like it's there. Like there's no, so this is all in the smart contract, and you can calculate it. However, the risk part is probably something that has to be done by a human being. It has to be done either served by our Oracle, served by a trusted third party, or again, it may be served through governance. So that's also something that we'll explore as we continue. Let's continue. There's also an emergency shutdown mode. This is probably a great idea to have, even though you never want this to happen. But especially when a code has been, it's just a very young, you probably want to have a way to just reimburse everyone manually. Because the idea of locking everybody's funds and burning them is probably worse. So, you have to basically balance that out with the risk of being rug pulled. When the vault is put into emergency shutdown, assets will be recalled from strategies as quickly as is practical, given on-chain conditions, minimizing loss. Deposits are halted, new strategies may not be added, and each strategy exits with the minimum possible damage to position, while opening up deposits to be withdrawn by users. There are no restrictions on withdrawals above what is expected under normal operations. Okay, so basically we're going to have this emergency shutdown lens, and I'll try to separate that from the ordinary code, because to also deal with an emergency shutdown contingency is just going to make our life so much more complicated. And in terms of the difference between Solidity and Viper, and there are many, and but fundamentally we can just pseudocode, read it up pseudocode. So even if even myself, I'm not a Viper coder at all. So, but I think we can live with that. So here we have a version set to a string constant, which is 0.3.5. We're importing ERC20, and we're also extending that interface, which means that it will be the is keyword on Solidity. We have an interface that specifies what a detailed ERC20 is, and it's just name, symbol, and decimals. And since we're in the vault, we expect, hey, Aram, how you doing? So we basically expect this to be the just the specification of the token representing your ownership of the pool. So, and something interesting about this, let me show you what I wrote in my own code. But when you're dealing with withdrawals, something you want to keep in mind is, how do you reimburse a person based on what they earned and based on what you owe to them? And so you probably will have to do either percentage. You're going to have to calculate a percentage. In this case, I get the total value that is locked in the contract. I multiply by the amount of tokens that the person wants to withdraw, and I divide that by the total supply of tokens, which means that I get the percentage, and I base that on the total value that I have in my contract. And that may be one way of doing it. Although another implementation, which is as valid, and you can see that in Aave, is that the tokens you own represents the exact corresponding collateral. So you always have a one-to-one conversion because your token increase with time. They literally, if I go back on Aave and I go here, even if I have like $1, you can see that the number goes up. It goes up every 2 seconds because every time a new block is issued, there's some sort of parameter in Aave that goes up, and that means that my balance goes up. It literally goes up. It's actually beautiful to watch. And if I redeem that balance, I will get back the exact amount of collateral. So there is no percentage being calculated. It's done in a different way. However, a more naive and faster way will be to use a percentage. So we'll have to keep our eyes on that. Next up, we have the interface for a strategy. This is, we're going to go into strategies, and that's how you separate your code between vault, depositing, managing funds, and strategies actually actively using the funds to get yield. So we'll have to figure it out. But basically, we have want, which is going to return the address of the token that the strategy wants to accrue more of. It's going to then have a parameter vault, which is going to be the address of the vault that the strategy is assigned to. It's probably a good idea to have each strategy be attached to a single vault, which is going to, again, in the case of withdrawing, it's going to make your life so much easier instead of having a strategy that could be used by multiple vaults, which means that some strategy may not have enough funds. Next up, we have is active. It just checks if that's working. Delegated assets. It's probably, no, this is a number. Delegated assets is a number. We'll have to see what that is, but I'm guessing it's probably the amount of funds that have been given. So the amount of want or the amount of tokens that have been sent, but I'm not sure. We'll have to figure it out. Next, we have estimated total assets. I'm guessing, again, the amount of balance that they own. Then we have the act of withdrawing. It's going to be a function that receives the amount and it returns a number, but basically just withdrawing, and migrate, which migrates the funds from one strategy to the other. The act of migrating, you can interpret that, and I go back to my personal script. The act of migrating, you can see it as the act of taking all of your money. In my case, I'm taking all of my money from Aave, and I'm repaying all of my debt. So if you see here, I have literally a loop, which will cost you millions of gas. So it's definitely not cheap, but on Polygon will be cheap. But basically, you can loop over until you withdraw everything, and then you can do whatever you want. You can migrate your funds. So I'm assuming the migrate function is going to play a core role in getting funds out and putting them there. And I'm not seeing an amount, which is interesting, but again, we'll see. But this leads me to believe that migrate will literally take all the money and put them in a new strategy. Next, we have guest list, interface that defines authorized, guest address amount. We'll see what this is. We have the transfer event, approval event. These are ERC standard events. Name public, yeah, ERC. This is all very familiar if you ever work with an ERC20 contract. And then we have the, and I love how they separated it. This shows like a nuance on the software engineering level. It literally shows like a step up from trying to just code something to actually building it in a way that is maintainable. They grouped up the basic ERC stuff, the number stuff related to numbers, and then the governance stuff or the management and admin stuff. So I just like that. I think it's cool. It's a nice touch. Then we have the strategy params, and this is defined as a struct. We have the performance fee defined in basis points, and I never remember what basis points is. BPS as percentage. I think it's 1/100th of a percentage. 1 basis points is 0.01%, 1/100th of a percent. Yeah, so it would be 1 basis point is this number right here, 0.0001. And this may actually explain why we see 10,000 when we're dealing with, is it going to be 10,000? Yeah, I think 10,000. So that explains why you see 10,000, because we're dealing in basis points. And every time you're dealing with finance, that's the scale. But engineer, as an engineer, you have to get used to that. Just like as a normal person, you have to get used to arrays starting with 0 instead of 1, because computer science. Anyway, you have activation. This shows a block timestamp. So I'm guessing it's a way to block or prepare the strategy before actually publishing. The debt ratio, this is really interesting, the maximum borrow amount. So the debt ratio, basically anytime you're doing yield farming, you always have you will most of the time have to deal with debt, because nobody will just give you money for free. Like that's not what's happening. So you need to have a very practical understanding of how you would farm manually in order to start understanding what Yearn is actually doing. But fundamentally, you always have to take a loan in order to be able to make money. It's just like buying a house so that you can rent it. You're buying the house, you're doing the mortgage so you can rent the house. And the debt ratio will represent how much you can, how big of a house you can afford, or how big of a house you're willing to afford before you're just going to be like, okay, that's enough, that's too much. Then we have mean debt per harvest, lower limit of the increase of debt since last harvest. So this brings a keyword harvest, which is a keyword that in the yield farming space is very widespread. And you also have harvest.finance, which literally takes that name. And the harvest function, I genuinely, I'm not sure exactly of what it's supposed to do, but the harvest function is a function that you always find in all of these contracts. And it typically either reinvests or it takes the profits and then it does something with them. So I'm not exactly sure of what exactly it will do. But as you can see, we have parameters that basically deal with increasing or reducing debt, which basically you can see debt as leverage, where debt is a way to either make more money or reduce your risk. Then we have last report. Last time a report occurred, I think this is due to automation. We'll see that later. Then we have the total debt, total standing debt the strategy has. Yeah, that's good. Total gain, total returns that the strategy has realized for the vault. And then the total losses, which are the everything that was lost for the vault. And we have these as totals, which means that they're not relative. These are going to be absolute numbers. So we'll see what happens there. Next, we have the strategy added, and that's just the event for saying that it was added. Strategy reported, it takes it actually indexes the address of the strategy, and then it shows the gain, the loss, the debt, and then you have the totals. So the events actually will show you the relative gain and relative loss, while the rest of these parameters will not. Then we have governance, update governance with this address. Yeah, just the governance, update management, guest list, rewards. Yeah, these are just events for changing management fee, guardian, shutdown, withdrawal queue. So we'll see what this withdrawal queue is. But I'm assuming this leads back to the fact that the governance is able to change the withdrawal queue ordering, which means that each strategy will pay out first when you need to withdraw. Next, we have the strategy update debt ratio. This is the act of the event that triggers when you change the debt ratio. Strategy update min debt per harvest. This is just changing the minimum debt. This is changing the maximum debt. The update of a performance fee, and this is the act of migrating to a new strategy. So this brings back that keyword migrate. And at this point, it's leading me to believe that migrating a strategy is not just moving your funds from one to the next, but it's actually moving the funds from a version of the strategy to the next version of the strategy. And we'll see if that's the case as we continue. Then we have strategy revoked. I'm assuming this just blocks the strategy. Removed from queue. This removes it from the list of withdrawals, and added to the queue, which adds it. Then we have a note. Track the total for overhead targeting purposes. Then we have a list of strategies which is gonna map between the address of the strategy and then the parameters. Okay, so this gives us, it means we're gonna use the address of a strategy to get back the strategy params, which show us all of the configuration, the debt, the loan, the totals, etc. Then we have the maximum number of strategy, which is 20, and this is a constant, so it's just social contract, and it's actually hard coded in the contract, so this is what it is. Degradation coefficient, not sure what this is, but 10 to 18 is basically 1 if. Let me see. Then we have withdrawal queue, which is gonna be a list of addresses that contains the number of maximum strategies. So this is a list of 20 addresses. And let's see the comment. Ordering that withdrawal uses to determine which strategies to pull funds from. It does not have to match the ordering of all the current strategies that exist, but it is recommended that it does, or else withdrawal depth is limited to only those inside the queue. Ordering is determined by governance and should be balanced according to risk, slippage, and volatility. Can also be ordered to increase the withdrawal speed of a particular strategy. And then the first time 0 address is encountered, it stops withdrawing. So again, this means that, and this may be a great pattern for Solidity developers, is that anytime there's an operation that is too complex, and but you still need it, you may as well just have it done by governance. So somebody else has to do it, and it also is flexible. So this may be a better way than having an upgradable contract that nobody's going to trust. So that's pretty good. Then we have the emergency shutdown, deposit limit, which is the maximum amount the vault can hold. The debt ratio, we just saw it, BPS less than equal to 10K, because 10K means 100% debt. And, you can't go over that. Although if you look at something like Aave, you'll see that the actual loan to values, where loan to value is the amount of money you have to put in for the amount of money you can get out, most of the times the loan to value is going to be something like 50% or 70%, which means that for every dollar you put in, you can actually only borrow 50 cents on the dollar. So you would expect that this number right here will reflect the strategy and the actual protocol that is actually going to be interfacing with. We have total debt, the amount of tokens that our strategy have borrowed, last report, block.timestamp, activation, block.timestamp, locked profit. How much profit is locked and cannot be withdrawn? We'll see what this has to do, but we'll see again. Locked profit degradation, rate per block of degradation. Degradation coefficient is 100 per block. Then we have rewards, which is the rewards contract where governance fees are sent to. Governance fees are sent to the rewards contract. That's okay. And that's actually an emerging pattern that I'm seeing. Basically, you're going to call rewards is the contract that the token holders will receive rewards from, either by staking or just by passively holding or stuff like that. And I'm starting to see that a lot. Governance fee for management of vault given to rewards, again, the management fee. And then you have the performance fee apparently given to rewards as well. So you have these two fees. And if I'm not mistaken, in the previous version of Yearn, they were 50 basis points, so 0.005 for management fee, and then the performance fee was something like 5% on the extra profit. And this was done, the performance fee was available only for active strategies such as flash loans or arbitrage strategies. We have max BPS, again, the basis points, it's 10,000. This number you'll see a lot every time you deal with finance. It's 10,000. Then we have the seconds per year. And this probably has to do with the, we'll have to see actually, but yeah, this is just seconds per year as a, again, as a number with an actual explanation. And this actually makes me think of a video by Tom Scott. If you want to check that out, is Tom Scott loses his sanity. You should definitely check this video out. This video talks about dealing with time zones and the time. So this video is awesome. I highly recommend you check that out. Tom Scott, I actually had the same reaction when I started working with times. So yeah. Then we have nonces. I'm assuming, yeah, it's to track the permits. Then we have domain separator. It's just going to be probably a string to just for the name. Domain type hash. We'll have to see what this is used for, but this is kekak 256 of EIP 712 domain. Let's check quickly what EIP 712 is. Ethereum type data structure for data hashing and signing. Yeah. So basically, the EIP 712 allows so software wallets, hardware wallets to actually show structured data. And it also makes your life easier when you're dealing with signatures. So perhaps once I start doing some NFT stuff, and if you're interested in the NFT stuff, let me know in the chat or in the comments. But once perhaps the permit type hash, and this is basically the hash of the permit function that is allowing, given the owner, it allows us a reward parameter and management parameter. Then the name override, the symbol override, and that's just to hard code an actual number. And then we have the guardian set to an address that is equal to message.sender. So guardian, we'll have to see what it is, but most likely guardian is somebody that can probably do a lot of interesting stuff. Let's see. Initializes the vault. This is called only once when the contract is deployed. The performance fee is set to 10% of yield per strategy. The management fee is set to 2% per year. Okay, per year. That brings back that seconds per year, because now you can actually calculate what each block is worth in terms of that. Then we have the initial deposit limit is set to 0. Deposit disability. It must be updated after initialization. If name override, the name will be Yearn combined with the name of token. If symbol override, otherwise you get the Y, which is normal. We have a parameter called the token, governance, rewards, management. Token, the token that may be deposited. Governance, the address of the authorized, that is authorized for governance interactions. Rewards is the address to distribute rewards to. Management is the address of the vault manager. We haven't seen this manager keyword pop up too much. We'll see it probably with a modifier later. And then we have name override, symbol override, and guardian. The guardian is the address authorized for guardian interactions, which defaults factor is 1. Okay, and normally you never go above 18 decimals, although I've seen projects that did. And I think they got mocked on Twitter. It was actually funny, but you know, it's just the smugness of Twitter where you get mocked for having more than 18 decimals. So we have the governance. We're just setting all these variables up, nothing particularly complex here. And then we also have this domain separator variable set to the kekak 256 of the domain type hash, Yearn vault. And again, this is for we look into more gasless stuff. API version returns the API version. Set name changes the name of, it requires it to be done by the governance, and it changed the name. Set the symbol, it allows it to change project change symbol after they launched. But yeah, I guess. Next up, we have two-phase commit for changing governance. Set governance. We receive an address. It has to be done by the governance, and it will set the governance to pending. And then, all right, so this is actually cool. So in a way, in order to change governance, where governance is the address or the multisig or the contract that can actually manage a bunch of stuff, they chose to have a two-phase commit, which means that the first time you're going to call set governance, and it will set this property called pending governance to the governance that it was received. So it will set it as pending. And then the pending governance has to make a request, because that's what this says, and it will then set the governance to the message.sender. So the governance has to be accepted by the other side as well, which may be, yeah, I mean, it's just the way to do it, I guess. It probably avoids mistakes or something like that. Next up, we have set management, changes the management address. Management is able to make some investment decisions, adjust parameters. And yeah, so that's what the management does. Then we have the guest list. Let's see, a guest list is another contract that dictates who is allowed to participate in a vault. Okay, so the guest list is basically a way to allow people to use it. And this actually makes me think of other protocols. And one of them that you will probably learn about later today at Bankless is Alchemix. And Alchemix uses Yearn to repay for that. They basically issue a token that will pay for itself. And I'm assuming that some of those vaults, especially when they're very experimental, cannot be accessed by everyone, and they you have to be put in the list. You basically have to ask to be explicitly put in the list. Set rewards will set the rewards address. Set locked profit degradation will change its profit degradation with a rate of whatever. We'll see what this is in a second. Set deposit limit, the maximum amount that can be deposited in a vault, and a performance fee, which we said is, it's based on what happens. We have the management fee, same thing. The Guardian, again, the Guardian can do a few things. We'll see it later. Then we have a way to set the emergency shutdown. And I love that the documentation is very thorough here. So it says activates or deactivates vault mode where all strategies go into full withdrawal. During emergency shutdown, no users may deposit in the vault, but may withdraw as usual. The governance may not add new strategies. Each strategy must pay back their debt as quickly as reasonable to minimally affect their position. And we'll have to see what this means. We'll see it in the strategy. And then only governance may undo emergency shutdown. See a contract level note for further details. If true, the vault goes into blah, blah, blah. Okay, basically this sets that. Then it sets the withdrawal queue. We already spoke about it. It's just a way to prioritize which one of these, which strategy should be used for withdrawing first and which strategy should be used for withdrawing last. I'm not seeing a deposit queue for strategies, so I'm assuming there has to be a different mechanism for doing that. We'll have to see. We have the ERC20 safe transfer. That's fine. As you know, the safe transfer will revert instead of just giving you a false result when it fails. It's way better to have something revert when it fails because otherwise people will be upset when they lose their funds. Next, you have transfer, which is defined as internal. And I like that I'm seeing this convention, the underscore transfer internal. So anytime you see an underscore function, you want to think, okay, this function is used internally in the code. It's not necessarily accessible anywhere else. So let's see, C note on transfer. And by the way, this idea of the internal function, this idea is great because typically you will write a simple function that receives all of the parameters and does a bunch of stuff. And that allows you, when you're developing, to set this to public, and perhaps you can set it to only owner. And you can use this pattern to write unit tests, debug your contracts, and write them real quick. And then you can set them to internal so that they're the unit tested functions and they work. I was checking the Uniswap v3 source code, and maybe I'll check that another day. But I think what they did with tests is really interesting, so we can learn a lot by checking that out. So I highly recommend you go and check the Uniswap v3 core because it's just a example of engineering, thoroughness. Let's say the test took like 10 minutes just to run the test, so it was cool. Next up, okay, we have the transfer. Basically, just send stuff. Nothing particular here. Again, transfer function, transfer from. This is all your ERC20 function, increase allowance, so decrease allowance permit allows you to spend on your behalf through EIP 2612. Let's just quickly check this EIP just to be sure we're on the same page. And anytime you can literally Google this stuff and you'll see it. This EIP 2612 is the permit, 712 signed approvals. And it basically means that you can approve another contract to use your funds by signing the Git. Okay, so that's cool. And it basically does its thing to set itself up. And I'm pretty sure you can literally copy all of this code from Open Zeppelin. Thank you, Open Zeppelin, for existing, I guess. So we have the total assets, issue shares for amount. Okay, so this is actually where we start getting into the more interesting stuff. We see to address amount uint 256. So we receive, it's an internal function that receives an address and an amount, issues amount vault shares to. It's going to issue this amount of shares to this user. Shares must be issued prior to taking on new collateral, or calculations will be wrong. This means that only trusted tokens with no capability for exploitative behavior can be used. So this is actually something that even Aave even the Aave even the Aave tokens may cause issues with this, because the fact that the number changes may throw off your math. So in this case, they probably will have a list of tokens they will accept, and I think this is just because they wanted to save. Exactly, they want to save gas. Basically, they want to save so much gas that they wrote it using assembly. Anytime you see where is the assembly? Actually, there is no assembly here. So anyway, they're declaring shares as a uint with 0, total supply, uint equals self.total supply, saves true-s loads. I'm really not sure what this means, but I'll trust it. So anyway, if total supply is greater than 0, we're going to set this precision factor to the precision factor variable. And then shares is going to be equal to precision factor times amount times total supply divided by self.total assets divided by the precision factor. So the shares that are going to be issued otherwise, the share amount is going to mint 1-to-1 normally. Otherwise, it will actually, and it's going to mint shares, right? Yeah. Total supply plus shares, balance of 2 shares. So given the amount of issues amount volt shares too, but technically this is not what this is doing. This is calculating what amount is given this input amount, and it will issue this shares amount. So I would, I guess I would say it, I would phrase it differently. This would issue shares, volt shares 2 given the input amount, and amount is used here as a way to, we have total supply divided by total assets divided by precision factor and then multiplied by precision factor. I'm assuming this is just to avoid rounding. They do it, they do a multiplication and a division here. You always do multiplications first. Next up, we have amount times total supply. And hey, Anime here, good to see you. How you doing? So we have the amount times the total supply, and then we're going to divide it by the total assets, which I'm assuming is everything that they have in control. So we'll see. And again, we're just issuing shares here. Next, we have the withdraw function with a non-reentrant modifier. That means that you can't have this being called multiple times on a single block. And we have the withdraw function, which has a parameter amount, which starts by default to be set to the maximum. We have the recipient set to message.sender. It will deposit amount token issuing shares to recipient. If the vault is in emergency shutdown, deposit will not be accepted and this call will fail. Measuring quantity of shares to issue is based on the total outstanding debt that this contract has, the expected value, instead of the total balance sheet it has, the estimated value. Has important security consideration and is done intentionally. If this value were measured against external systems, it could be purposefully manipulated by an attacker to withdraw more assets than they otherwise should be able to claim by redeeming their shares. So this is actually, there may be a big lesson here, but we're seeing that they're using the total debt is based on the total outstanding debt that is contract as expected value instead of the estimated value. I'm not sure what expected versus estimated value difference is going to be, but and we'll see it as we continue reading. But the thing I'm getting here is that the contract has to basically have a reference that avoids it being exploited from the external, and that may be something that I haven't considered in my newbie solution. So I'm definitely going to pay more attention on this. Next up, we see on deposit. This means that shares are issued against the total amount that the deposited capital can be given in service of the debt that strategies assume. If that number were to be lower than the expected value at some future point, Depositing shares via this method could entitle the depositor to less than the deposited value once the realized value is updated from further reports by strategists to the vault. So the realized value, the expected value, the estimated value. This deposit as shares a ratio against the total amount. The deposit can be given in service to the debt the strategist assume. If the number were to be lower than the expected value of some future depositing share with this method could entitle the deposit to less. Basically, there is a potential exploit that is based on using the current debt versus the expected amount of money or value that will be extracted by strategy. And this basically the difference between the expected value, the fact that you're taking in debt, and the fact that you're going to have a different realized value means that there is a potential exploit here. And so for the sake of consistency, they're going to use the expected value instead of the total balance sheet. Okay. Care should be taken by integrators to account for this discrepancy by using these view-only methods of this contract, both off-chain and on-chain, to determining if depositing into Vault is a good idea. No re-entry withdraw. Okay, and this is the function deposit. Okay, so function deposit. So we're saying that it can't be done during emergency shutdown. You recipient not in self and zero address. So the you can't auto deposit your own funds and you can't be the zero address. Amount is going to be set to the amount received. If amount is not specified, transfer the full token balance. This is a shortcut to allow you to have the maximum amount by having no parameter. Otherwise, it's going to ensure that the limit for total assets is respected. Self-deposit, okay, because we have a deposit limit for every vault. So this is just ensuring that the vault doesn't accept more funds than it's programmed to. Then we're going to assert that the amount is greater than 0. And then we're going to check that the address is not 0. And then we're going to check that the guest list is returning authorized on this account. So you have to be authorized for this. And this can be done only if the guest list is 0. So you now know that if you remove the guest list, everybody is allowed to interact with the vault. Then we do a safe transfer and we return shares just in case someone wants them. Okay. Next, we have share value. It returns price 1-to-1 if the vault is empty. And I'm guessing it calculates what the share is actually worth if it's not 1-to-1. So let's see how they do that. I'm going to give you my example to withdraw. And my example is based on just withdrawing from Aave. Let me see. So in my case, the way I do it is I get total value, which is equal to the balance of the token that I want. And then I add what I deposited on Aave. And then I subtract the amount that I owe because I know that the amount that I owe is not mine. And the amount that I deposited is, and it's always 1-to-1. That's because I'm using Aave. And then I'm just adding the balance that is currently floating in the contract. And then given that, I can just do a percentage given the amount of shares and the total supply. So let's see instead how a more sophisticated system such as Yearn will do it. Okay, it receives the share uint value. It then defines the locked funds ratio, which is equal to block.timestamp minus self.last report times self.locked profit degradation. So basically there is a amount of funds that are going to be locked, and it does that by calculating this profit degradation times, which is a variable we saw, basically 1 with 18 zeros, or something that the governor set. And then that will be multiplied by the timestamp, the current one, minus the last time that a report happened. We have to see what last report means, but that's basically what this does. Then we have free funds is equal to the total assets from this contract. The precision factor was that variable we used to multiply and divide just to avoid rounding errors. Then we see if locked funds ratio is less than the degradation coefficient, where degradation coefficient is a constant, then free funds is minus equals to the locked profit, the amount that is locked, minus the precision factor, which we remove, yeah. So it's going to be equal to locked funds ratio times locked profit, the locked funds ratio, the ratio of funds that are going to be locked, multiplied by the locked profit, the amounts of funds that are going to be remaining here, divided by the degradation coefficient. So if the locked fund ratio is less than degradation coefficient, the locked fund ratio times locked profit divided by the degradation coefficient. So the degradation coefficient, and then we have the ratio of funds we locked multiplied by the amount that is locked. And that we this will change our free funds to be equal to that. So basically, the locked fund ratio and the degradation coefficient are expressing a way or a number. They're used to figure out a number of funds that are gonna be unlocked. So this is the unlocked part, and this is the locked part. And the free funds is gonna be equal to the subtraction of the locked profits minus the part that has been unlocked. So this basically is dealing with the locked stuff, which I'm not sure why it's locked, but we'll figure that out. We have the locked stuff, and then we have the free funds, and we're just removing all the stuff that is locked by using this math right here. And then given this, we're going to return, again, precision factor we're going to ignore, shares times free funds, shares, amount of shares, multiplied by free funds, divided by total supply. And that gives us the share value. Yeah, that makes a lot of sense. Beside the, I'm not sure why there's the locking, but ignoring the locking, we're simply having amount of free funds, which is the total assets minus the locked. So it's basically everything that this contract is holding. And then you multiply that by the shares and you divide it by the total supply of shares. So since the entirety of the vault is denominated in one token, then this makes perfect sense. And there's no need for any further correction. While and since my example that I written also is denominating in one token, then this makes a lot of sense. Otherwise, you may need to also add these ideas of get rate, where you basically use an oracle to calculate your the value from a different currency. In this case, from ETH to Matic. That said, again, simply the value of a share is equal to the amount of shares divided by the total supply multiplied by the funds that are free. And then we have this precision factor, which is added and removed to avoid rounding. I think I will take this advice of having a precision factor because I've had situations where my numbers were off by one. And so this is how you avoid rounding errors, I guess. Sounds cool. Then we have shares for amount. I'm guessing it's literally the same thing, but instead of using share, the single share, it's going to use the amount that we gave. So that's basically that. Then we have the max available shares, which determines the maximum quantity of shares this vault can facilitate a withdrawal for, factoring in assets currently residing in the vault, as well as those deployed to strategies on the vault's balance sheet. Facilitate a withdrawal for, factoring assets currently residing in the vault, as well as those deployed to strategies on the vault's balance sheet. Okay, so this is where we start getting into multi-strategy, basically having assets in multiple places, and it will simply return the all the shares that this vault can allow you to withdraw, basically. So let's see. Regarding our shares are calculated, see dev note on deposit, which we saw up. And if you want to calculate the maximum a user could withdraw up to, you want to use this function. That's awesome. Note that the amount provided by this function is the theoretical maximum possible from withdrawing. The real amount depends on the realized losses incurred during withdrawal. But this is on shares. Note that the amount provided by this function is the theoretical realized losses. So the one thing that perplexes me about this comment is that we are asking how many shares can be served. So I believe that even if the shares were to take a loss in the token denomination, you could still withdraw them. You just lose value. Your token is worth less, but you can still redeem those shares. Although there may be some other that prevent that. But again, this means that we may have to go back to withdraw, perhaps as we continue. We're halfway the file. Perhaps we will go back to withdraw to figure that out once we have more context on the entirety of the code. Then we have we return the total quantity of shares this vault can provide. Amazing. So self shares for amount, which we saw before. Amazing. Which checks the shares for amount given the self token of balance. So given the balance of this contract, the balance of this token, it so basically it takes the balance of token that this contract has, and it gets the shares for amount. It gets the shares that are serviceable. And then for strategy in withdrawal queue, if the strategy is 0, it will break because the last strategy is denominated by a 0. And then it will check, it will just add shares from shares of amount given the total debt of the strategies. Total debt. So the max available shares gives you the shares for the amount given the sum of the total debt of each strategy. So it's not the assets in the strategy, it's not the deposited in the strategy, but it's the total debt. I'm honestly not sure why. Maybe we'll see that as we go in the strategies code. But this may also be a way to, because you should, given, yeah, that may be an intuition that I'm getting, but this is pure speculation. But let me show you something with Aave that is really easy to understand. So if you deposited one Matic, you can borrow 50 0.5 Matic, right? That's all you can do. If you deposit 1, you can borrow 50 because that's the LTV. That means that this 50, I can withdraw at any time as long as I repay them. Because as long as my L factor is above a threshold, and we saw that there is a min and a max, then I can always withdraw this without any risk. There is 0 risk to withdrawing this. So that may be an intuition as to why it's doing this. Because again, this is for sure the amount you can withdraw. The one in the deposit may be leveraged. And I can show you an intuition for that. It's very simple. I have 1 here and I have 0.5 here. I can, at this point, I can't borrow more because I'm above my L factor, but I can actually, quote unquote, borrow more by withdrawing from here. I can withdraw up to 0.22, setting my L factor to a lower number, right? Which is going to basically compromise my L factor. I'm risking of getting liquidated. However, at this point, there is still a way for you to withdraw the 0.5, but this number is basically, if you were to withdraw anything from the deposit, you will lose your money, basically. You literally can't. Aave will actually revert. And I'm gonna give it back, whatever that was. 0.12, 0.22. Yeah. All right, so I'm guessing that's why we use total debt in the max available shares, but again, we'll investigate. Then we have report losses. It's an internal method, receives a strategy and an amount. Loss can only be up to the amount of debt issued to the strategy. Total debt, strategy is total debt. Assert that total debt is greater than equal to loss because you can only lose as much as what was owed. That makes sense. And then the total loss, yeah, just change these variables for the total debt and total loss for the strategy. Also, make sure we reduce our trust with the strategy by the same amount. That's actually really interesting. So we get the debt ratio from a strategy. We get the precision factor, which is just like this entire precision factor thing. I'm not sure if there's an easy way to avoid this, but maybe there would be like a utility function called precision math, where it's just where you basically always put the precision factor at the beginning for multiplication and for division. So I just need to learn to ignore it when reading this code. And then we get the ratio change is equal to the minimum of the loss times the BPS, which is 10,000, divided by the total assets, and then and the debt ratio. So we either take the debt ratio or we take the loss times the BPS divided by total assets. that changes that's used to declare this variable ratio change, which will change the debt ratio to a number that is less than that. So the debt ratio gets decremented by ratio change, which means that now our strategy can take up to debt ratio debt, which is less. And I'm guessing it's, again, as I said, a way to reduce trust in the strategy because the strategy is not performing as expected. And then I just change the debt ratio less by lowered by the ratio change as well. So we're seeing that this change of the ratio changes both in the debt ratio of the strategy and the debt ratio that we have. And that may be because this strategy is taking some debt and we are taking some debt as well. So again, another thing to keep in mind. Next up, we have withdraw. Max shares, yeah, by default set to that. Recipient set to you. Max loss set to 0.1 basis point, 0.01%. And that may be a way to basically block withdrawals. And this actually gets us back to the stuff we were looking at before. Let's see what we got. Withdraws the calling accounts token from this vault, redeeming amounts underscore shares for an appropriate amount of tokens. See note on set withdrawal queue for further details of withdrawal ordering and behavior. See note on set withdrawal queue for further. Okay, yeah, because it's gonna use the queue from the vaults queue. Then we see measuring the value of shares is based on the total outstanding debt that this contract has, the expected value, instead of the total balance sheet that it has, the estimated value. We're gonna take the outstanding debt instead of the total balance sheet, the estimated value. And I think this goes back to this idea that I have 1 and 50, and if I deposit my 50, because I'm doing the strategy where I take the borrowed money and I put it back in Aave, then I still have borrowed only 0.5, but I currently will have deposited 1.5. And so if I ran the math on this, I am massively overinflating my numbers, which are, it's bound to cause issues. So I may have to change my own math and base it on the borrowed amount, because given the borrowed amount, I can always get back the real amount, but we'll see again. And blah, 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 consideration, if this value were measured against external systems, it could be purposely manipulated by an attacker to withdraw more assets than they otherwise should be able to claim by redeeming their shares. On withdrawal, this means that shares are redeemed against the total amount that the deposited capital had realized since the point it was deposited, up until the point it was withdrawn. On withdrawal, this means that shares are redeemed against the total amount that the deposited capital had realized. The shares are redeemed against what the deposited capital realized. Yes, since the point it was deposited up until the point it was withdrawn. Okay, so that means that your shares are taking in the value that your shares, the collateral that corresponds to the shares, generated from the point it was deposited from until the point it was withdrawn. So basically, you're getting the interest that those shares generated. If the number were to be higher than the expected value at some future point, withdrawing shares via this method could entitle the depositor to more than the expected value once the realized value is updated from further reports by strategies to the vault. The number were to be higher than expected at some point, withdrawing shares via this method could entitle the depositor to more. So yeah, if you use the stuff you borrowed, you would expect to be able to earn more, and that may you basically will end up receiving more than what you should be receiving, and that can be exploited. Under exceptional scenarios, this could cause earlier withdrawals to earn more of the underlying asset than users might otherwise be entitled to. If the vault estimated value were otherwise measured through external means, accounting for whatever exceptional scenario exists for the vault, they aren't covered by the vault's own design. Okay, so that means that there may be an arbitrage opportunity. I'm honestly not sure, but if we're gonna spend the next 100 hours exactly figuring out why this is the case, there may be there definitely is a lot more to uncover literally in these words right here. Then we have the parameter max shares, how many shares to try and redeem, recipient, the guy, the address that receives, and max loss is the acceptable loss to sustain the withdrawal, because every other strategy has to cascadely earn and lose value. We have the shares, may reduce this number below. That's the max shares. We have the max loss, which can only be up to the BPS, because you can only take a 100% loss, which goes back to the previous idea of on lockdown, when the vaults are locked. There may be losses, but you can specify a slippage on your losses, which is great. We're going to check that you can only try and withdraw up to your maximum balance. Limit to only the shares they own. Yep. Ensure we're withdrawing something. It doesn't let you waste gas for no reason. And then it will get the value by calculating share value of shares. So now this is the value of the shares. Given the amount of shares, it will tell you how much they're worth. Then you have the total loss. And if value is greater than the balance of the token that this vault has, that means that the vault has to withdraw from the strategies. We need to go for some to get some from our strategies in the withdrawal queue. And if you were to write your own yield farming contract, something that I did is I withdraw everything. And this is actually, because it's so much easier to code, just divesting, and you're going to withdraw until you can repay everything. And you're just going to repay everything and just withdraw everything. That's highly inefficient because you're wasting gas, because you're going to have to redeposit and you're going to have to rebalance anyway. So this problem that the Yearn team solved by having a list of strategies, it's actually something that every smart contract developer will have to face. So let's see, we need to get some strategy, blah, blah, blah. This performs forced withdrawals from each strategy. Forced withdrawals. During forced withdrawals, a strategy may realize a loss. That loss is reported back to the vault, and the will affect the amount of tokens the withdrawer receives. We gotta do like a suggested fix here for a typo or something. Reference in new issue. And the will affect the amount of tokens reported back. The loss is reported back to a vault and will affect the amount of tokens that the withdrawer receives for their shares. They can optionally specify the maximum acceptable loss in basis points to prevent excessive losses on their withdrawals, which may happen in certain edge cases where strategies realize a loss. Okay, so let's see. For strategy, we basically iterate over each strategy. We're going to break when we get to the empty strategy. The balance of the vault is calculated every time that we do the loop, and we check at which balance we are. If value is less than vault balance, we're done. So this is how you will stop withdrawing, because value is less than equal to vault withdrawal. So in a simple example that I have, where I loop, I will check for current less than amount. If current is less than amount, I will continue looping. Otherwise, I will eventually stop. Then we have amount needed is going to be equal to value minus vault balance, because we got the new vault balance. And so now amount needed is going to be the minimum between the amount needed and the total debt of a strategy. And that's because the strategy cannot withdraw more than the total debt, because we have this intuition that the total debt actually represents the real value that the strategy has, because the total debt is a way to cap the amount that the strategy can immediately turn into usable tokens. If amount needed is 0, continue. Nothing to withdraw from this strategy, because there is no total debt, or amount needed is 0. Amount needed should never be 0, because you will break here. If value is less than vault balance, the value, let me see, amount needed is equal to value minus vault balance, and vault balance is the balance that the token that this vault has of token. So I have this balance, and then if value is less, we're done. where value is the parameter up here, which is the shares value that we need to repay. So anyway, if either of these is 0, it means that we're going to skip the strategy. Force withdraw amount for each strategy in order to in the order set by the governance. So loss strategy dot withdraw amount needed, and you literally calculate the loss by calling the withdraw function. And that withdrawn is equal to self.token.balance self minus vault balance, because that's what you withdrawn. It's equal to the vault balance token dot. Yeah, basically this is the difference between what you just received and the amount that you had. And if loss is greater than 0, value minus equal loss, total loss plus equal loss, and self.report loss. So the withdrawer is going to incur the losses from liquidation, or basically it's going to incur these losses here. So, and that's cool, or at least it's really, yeah, it's cool. It's cool implementation, because what's happening is that we're getting the loss for the strategy here. And if loss is greater than 0, then we're also going to reduce the value, which means that the loss is not, the system is not taking the loss. The loss is being passed on to the withdrawer. So if you try and withdraw too much because you're in a hurry, you pay that. It's not paid by the protocol. So that's actually clever. It's a really clever solution. Then we have total loss plus equal loss, and then you report a loss, which yeah, just probably just emits an event and maybe updates a global variable. Now reduce the strategy's debt by amount withdrawn, realize returns. This doesn't add to returns as it's not earned by normal means. Strategy dot total debt minus equal withdrawn, because there's no longer that, and self total debt is minus equal to withdrawn as well. Okay, and then we're out of the loop, which is really convenient by Python, the fact that the loop is nested, so it's actually easier to see. And we have withdrawn everything possible out of the withdrawal queue, but we still don't have enough to fully pay them back. So adjust to the total amount we freed up throughout forced withdrawals. We've done everything possible, but we still don't have enough to fully pay. So just to the total amount we freed up through forced withdrawals. Vault balance, this is the vault. Value is greater, then value is going to be equal to vault balance, and self shares for amount value plus total loss. And it's going to burn the number of shares that corresponds to the vault has on hand, including the losses that were incurred. So basically, in the case in which you're withdrawing so much that the vault can't even pay you back, it basically will do this act of setting the shares to the shares equal to the value and the loss. So that way you are basically paying those losses. And I'm guessing this is how you will be able to go back to 0 in terms of withdrawals. Well, if you didn't do this, you would still have some, you may have some shares left because some shares are worthless because of the loss that you incurred. Then you have this loss protection is put in place to revert if losses from withdrawing are more than what is considered acceptable. So this happens here. That is this the best they can do though? So basically, because this assertion will make the call fail. It means that you literally went, your worst case is you went through every strategy, through everything to be able to do this. And then it will fail here, which means that you're gonna pay, I'm assuming like, yeah, 99% of the transaction cost, 90% of the transaction cost, you're gonna pay it because you put the slippage here. So I guess if you're really unlucky, that's what happens. Although, you will basically need to be the sole owner of the vault to, I guess, even consider this. But yeah, there may be a scenario where I think it makes sense because the alternative will be for every withdrawer to always pay for each check at every loop. And so every single person's withdrawal will be more expensive. While this situation will happen exclusively if you're literally withdrawing like 90% of you went through every strategy and you've withdrawn a ton, and then you have slippage due to liquidation. So this will be like, it's not really, I think it's fine. Basically, you're going to lose a lot of gas if that happens. But again, I think you probably would, you basically the one person that can take that hit. And then we see, yeah, it's basically done. Next, we have a view method called price per share. It gives the price for a single vault share value is equal, yeah, share value with self.decimal. Yeah, it's basically the value of one share, and you use the share value function, which we saw before was a really pretty straightforward function, plus our the rounding factor. Next, we have organized withdrawal queue, reorganized withdrawal queue based on the premise that if there is an empty value between two actual values, then the empty value should be replaced by the later value. Okay, so this seems like a way to clean up the queue so that you ensure that the last value in the queue is the zero address, because the zero address in every of these loops, it signifies the ends of the queue. So that makes sense. Then you have add strategy, which receives the address, the debt ratio, the min per harvest, max per harvest, and the performance fee. Add strategy to the vault. This may only be called by governance. The strategy will be appended to withdrawal queue, called set withdrawal queue to change the order, which we just saw up here. And then the address of the strategy to add, blah, blah, blah. This is parameters we saw already. We're going to assert the withdrawal queue is not full. Now we're going to assert the withdrawal queue maximum strategy is -1 is 0. So there is a empty slot in the queue. Then we're going to assert that there is no emergency shutdown, and then the governance is doing this. Then we're going to say that the strategy cannot be receive also this strategy, and then it will set the withdrawal queue. It will basically put the strategy at the end of the withdrawal queue, and then it will call organized withdrawal queue, which we saw will simply sort them. I'm assuming it will sort them by just cleaning up the zero address and putting the zero address at the end. This is not a way to define the sorting order of the withdrawal queue. It will literally just append it and then clean up the list. Next, we have update strategy debt ratio. It changes the quantity of asset strategy may manage, the quantity that an asset strategy may manage. This may be called by governance or management. It requires that it's either management or governance. It requires that the strategy is active. Then debt ratio minus equal the debt ratio of the strategy. So it will take the debt ratio from the vault to the strategy. Then it will set the strategy debt ratio to be equal to debt ratio, where debt ratio is this number right here. And then it will increase the debt ratio of the vault to this debt ratio value. It will assert that the debt ratio cannot be above 100%. You can't. And then it will just be done with it. Then we have update strategy min debt per harvest. It will just change the minimum debt per harvest call. We don't know what harvest call is, but we'll figure that out. We update the strategy max debt. We saw that. Then we update the strategy performance fee. The performance fee, strategy performance fee, it will just change the performance fee, which is the extra fee that you get on return above expected. And then we have a revoke strategy, which basically removes the debt ratio, sets the debt ratio of the strategy to 0. And revoke strategy is you would assume that the strategy gets deleted, but what actually happens is that you just put the debt ratio of the strategy to 0, which basically means that the strategy cannot receive anything. It cannot borrow. So we'll see exactly what that means as we get into the strategy code. Next, we have migrate strategy, which migrates the strategy, including all assets from old version to new version. Okay, it moves all assets, as we said. And let's see what this says. This can only be called by governance. The strategy must successfully migrate all capital and position to new strategy, or else this will upset the balance of the vault. The new strategy should be empty, and you have no previous commitment to this vault. Otherwise, you could have issues. Let's see, it cannot be done by governance. The new version cannot be 0. The activation of the old version needs to be greater than 1, greater than 0, so it's active, while the activation of the new version needs to be 0. Strategy param self-strategy old version. We're getting the strategy param from the old version. We're revoking the old version. We're setting the debt ratio of this vault to the debt ratio of the new strategy, of the strategy, which is the old strategy currently. Then we're setting the old version total debt to 0 because we're migrating it. Then we're creating this new strategy with these new params that we got off of the old version. And then we're going to migrate. We're going to call the migrate function on the old strategy. And then there's this loop for EDX in range, maximum strategy, self-dot withdrawal queue, EDX equals old version. So self-dot withdrawal queue, EDX equals old version. If, okay, finds the old version and puts the new version in the place of the old strategy. Then we can revoke. We saw revoking a strategy just requires that it can be all done by governance strategy, message in strategy, self-governance, self-guardian. Can all be done by the strategy, the governance, or the guardian, and it revokes itself. We can add the strategy to the queue. It's basically a way to just add it to the end of the queue. Then we remove strategy from queue, same thing, just removes it, and then it calls organized withdrawal queue, which is the way to remove empty spaces. Then we have the debt outstanding. So this is a new thing, the debt outstanding. See note on debt outstanding, which is probably down here. And we have a precision factor. So we're just doing math. Given the strategy, it's going to get the debt ratio of the strategy. It's going to multiply by the total assets of this vault. And then it's going to divide it by the 100% basically. So it seems to me that the debt outstanding is equal to the amount that the strategy took divided by the amount that the vault has, multiplied by the amount that the vault has, divided by basically 100%. So this is the strategy debt limit. Yeah, it's just the percentage of how much the strategy can take in terms of total assets. And then we're going to use this debt limit. Let's see, we declare strategy total debt by getting the total debt from the strategy. And then if it's on shutdown, we're going to return strategy the total debt. Otherwise, we're going to check if strategy the total debt, this variable here, is less than strategy debt limit, then we're going to return 0, which means that there is no debt outstanding. Otherwise, the debt will be equal to strategy total debt minus strategy debt limit. Let's think about this for a second. We got the debt limit, which is the percentage of the debt ratio multiplied by the total assets. So the debt ratio is already a percentage. And then the total assets is a value. So the percentage of debt that the strategy can have at max, that's that number. This is the strategy debt limit. And then you have the total debt, the actual value that the strategy is taking in debt. And what he's saying here is that if the strategy total debt, the amount that the strategy took in debt, is less than or equal to the debt limit, then we're going to return 0 because, yeah, debt outstanding, because basically the strategy can return this money instantly, these tokens instantly. It doesn't have to repay anything. Otherwise, it's going to return strategy total debt minus strategy debt limit. Debt outstanding is a function that determines if the strategy in the past, blah, blah, blah. Yeah, basically it's using this function up here. So it's just the external version of it. Then we have the credit available. Let's see, the credit available, if it's in emergency shutdown, it will return 0. It gets the precision factor, which again, I need to ignore when I see it. Then we get the total assets. And basically we get the debt ratio of the vault multiplied by the total assets divided by the basis points. So it's a percentage between the total assets and the debt ratio. And this is the credit available because this is the amount of stuff that we're willing to borrow, I'm guessing. And then we have the total debt. We set the total debt here. We have the strategy debt limit, because again, we're looking at the credit available for a strategy. So we have the strategy debt limit, which is equal to the debt ratio of the strategy multiplied by the total assets of the vault divided by the basis points. So it's a percentage of all of the debt that the strategy can have given the total assets of the vault. Then we have the strategy total debt. We actually take the actual debt. Then we have the min debt per harvest and the max debt per harvest. And so if, and we see the comment exhausted credit line. So if the strategy debt limit, the maximum number, is less than the strategy total debt, or the vault debt limit is less than the vault total debt, then yeah, we have no more credit available. If the debt limit has been reached or the vault debt limit has been reached, there is no more credit. Otherwise, let's see, available is equal to the strategy debt limit minus the strategy total debt. And then we're going to have the minimum between the available from the strategy and the available between the vault. And that's, again, because we're checking how much credit is available to the strategy. And then available is equal to the minimum of available and the balance of tokens that we have. Can only borrow up to the contract as in reserve, okay? Because you don't want to run near 100%. Same idea that you can only, if you deposit 1, you can borrow up to 0.5 or in this case up to 0.99, although we'll have to see what the total debt variable looks like. And then we see here, adjust by min and max borrows limits per harvest. If available is less than strategy min debt per harvest, then there's nothing available. And otherwise, it's going to return the minimum between the available and the strategy max debt. Because, yeah, basically, if we're trying to borrow cents on the dollar, we're just going to ignore that. And otherwise, we're going to get the minimum between what is available and the max so that we don't go over the max per harvest. Then we see credit available, which is calling that function. Let's see the context for it. It's the amount of tokens in a vault the strategy has access to as a credit line. This will check the strategy's debt limit as well as the tokens available in the vault and determine the maximum amount of tokens, if any, the strategy may draw on. In the rare case the vault is in emergency shutdown, this will return 0. Okay. Then we have the expected return. Finally, we see expected return. Let me just do a peek of what we're going to have later. Deposit limit, expected return, assess fees, report. We have quite a little longer to go, and then we have sweep. We're gonna finish this file, and then I'll take a quick break, and I'll also do the strategy file. So let's see the expected return. Let's actually just because as you can see, we have the underscore expected return, which is the internal version, and then we have the external version, and the external version has a comment, so it's probably a better idea to just skip ahead and check this and then check the other one. So the expected return, we receive a strategy parameter, and then and it can even be called by the strategy itself. That's the default value actually. And then the comment says that it provides an accurate expected value for the return the strategy would provide to the vault the next time report is called. So it provides an accurate expected value for the return the strategy will provide to the vault the next time report is called since the last time it was called. The strategy is the parameter, and it returns the anticipated amount the strategy should make on its investment since the last report. Let's go and check it out. Expected return receives the strategy address. Strategy last report will be the last report here. It will check the time by comparing the block.timestamp minus the last one. This is this variable here. It's going to check the total harvest time, which is equal to strategy last report minus the activation time. So this is the total time. If time since last harvest is greater than 0 and total harvest time is greater than 0 and strategy is active, then if either time is 0, we can short circuit to 0. Okay, that's cool. But basically, if everything works, then precision factor, we get the precision factor, and then we calculate the total gain of the strategy, multiply the time since the last harvest, divided by the total harvest time. So it's basically a percentage gain, and we have this expected, basically the expected return is equal to how much the strategy already got, multiplied by the time since the last harvest, divided by the total time. So it's just a percentage that allows us to figure out what we got and what we expect to get. We see this a function called available deposit limit. It checks that the deposit limit is equal to the total assets. And if the deposit limit, and it returns the difference between the deposit limit minus the total assets, otherwise it returns 0. Okay, then we have assess fees, which is the internal function. So let's check the external first. Seems like it's used in this big report function. So I'll check the report function first, and then I'll go back to the assess fees. Report will receive a uint for gains, a uint for losses, and the debt payment as a uint as well. Reports the amount of assets the calling strategy has free, usually in terms of ROI. The performance fee is determined here of the strategy's profits, if any, and then sent to governance. The strategy's fee is also determined year of profits to be handled according to the strategies on the next harvest. This may only be called by a strategy managed by this vault. For approved strategies, this is the most efficient behavior. The strategy reports back what it has free, then vault decides whether to take some back or give it more. Note that the most it can take is gain plus underscore debt payment, and the most it can give is all of the remaining reserves. Anything outside of those bounds is abnormal behavior. Okay, so we have a most, gain plus debt payment, and now this is a take, and then most you can give is all of the remaining reserves. All approved strategies must have increased diligence around calling this function, as abnormal behavior could become catastrophic. Yeah, if all these numbers go out of the bounds, the entire system stops working because it's all based on the strategies reporting the proper numbers, which basically means higher emphasis on the code that the strategies are running. So we see param gain, amount strategy has realized as a gain on its investment since the last report and is free to be given back to the vault as earnings. So a gain, as we just define it, is going to be the float, the amount of tokens that the strategy has and that it's no longer using and that the vault can actually take for profit. The loss, it's a loss on investment since the last report and should be accounted for on the vault balance sheet. So this is stuff that has been lost. And it could be, for example, by paying higher interest on other tokens. Then we have the debt payment. It's the amount the strategy has made available to cover the outstanding debt. Okay, so this is the amount of token that the strategy can use to pay the outstanding debt. And then it will return the amount of debt outstanding if total debt is greater than debt limit or emergency shutdown. All right, so let's see. We assert that the strategy is active. We want the balance of the token of the sender to be greater than equal to gain plus debt payment. Let's see what message of senders. I'm assuming this is done by the strategy. Yeah, strategy is message of sender. So the strategy needs to have a balance that is greater than gain plus debt payment, can be greater or equal, which means that basically if this function is called the exact time the strategy takes a profit, then the balance should be exactly equal to gain plus debt payment. Well, if this is delayed a little bit, then the strategy may also have a little bit more in the balance of, and as such, it could just not have it reported yet. And if loss is greater than 0, we're going to call the report loss function. We have total fees, which is going to assess fees of message sender gain, which means that it will assess both management fee and performance fee and issue both as shares of the vault. Issue both as shares of the vault. Assess fees given message.sender and gain. Then it will set the total gains to p plus equal the gain that were reported by the vault, and it just sums them up. Then it will set the variable debt, this variable debt, which is a Yearn256, to the result of the debt outstanding function, which receives the strategy, basically gets the strategy.debt outstanding, the debt that still has to be paid. And then it will call debt payment. The amount that can be paid will be equal to the minimum between the debt that is outstanding and the debt that the strategy can afford to pay. If that payment is greater than 0, we're going to remove that payment. We're going to remove total debt, and we're going to set debt to minus equal debt payment. And I'm guessing we're going to use that to repay the debt. I'm not seeing the actual repayment of the debt. It's probably going to come up later. Then we see credit is equal to self.credit available or message.sender. Again, we get the credit available for the strategy. If credit is greater than 0, we're going to set total credit plus equal to the credit that we got. And then we're going to also increase the total debt of the vault to be plus equal the credit that the strategy has. And then it says give, take, balance to the strategy. I'm guessing this is where we're going to do the rebalancing. So now we have total available, and that's going to be equal to the gain, the amount that was gained, plus the debt payment, the amount that can be used to pay off debt. In total available is less than credit, then credit surplus, give it to the strategy. Total available is less than credit, then we're going to do a Safe transfer from self.token.address, ERC self. Basically, we're gonna do a safe transfer of the token from the strategy. Give to strategy. Token.address message.sender. So this is actually not the default ERC20 send method, or at least it doesn't look like it to me, because this is taking the address of the token. So I'm guessing now this is a safe transfer of this token. And and this is a safe transfer of this token to message.sender, to the strategy, for the amount that is equal to credit minus total avail. So that's what it is. And then if total avail is greater than credit, then we're going to do a transfer from the message.sender, from the strategy to this contract for the opposite value, the total avail minus credit. Update reporting time, we get the timestamp for the last report. We set that also to the thing, and then we have the locked profit, which is equal to the gain minus the total fee. Profit is locked and gradually released per block. It's gain minus total fees. Then if the strategy's debt ratio is 0 or self-emergency shutdown, we're going to call strategy.estimated total assets. Take every last penny the strategy as, and yeah, basically it's going to take everything. Let's see what sweep. Actually, we haven't checked the function up here called assess fees, which receives the strategy and then a gain parameter. Precision factor, yeah, we get the management fee is equal to the total debt minus the delegated assets, which we don't know what it is. We'll see it later. And then multiply by the difference between the timestamp, the current time minus the time of the last report, multiplied by the management fee. So we're basically getting a percentage. Yeah, we're getting a percentage based on time of the difference between the total debt and the delegated assets multiplied by the management fee. So we're getting a cut of management fee. And it only applies under certain conditions. We have set to 0. If gain is greater than 0, then the strategist fee is equal to the gain multiplied by the performance fee divided by the max BPS, where gain is being self-reported by the strategy. And then we have performance fee, which is equal to precision factor times gain times self.performance. So we have gain times performance fee. Again, gain as a the performance fee as a percentage. So we just take the percentage of gain times performance fee divided by max BPS to do the performance fee. And then we do total fee is equal to performance fee plus strategy fee plus management fee. If the total fee is greater than gain, then the total fee is equal to gain. We said that. Then if the management fee is equal to gain minus the performance fee minus the strategy fee. So if total fee is greater than gain, total fee will be capped to gain, and management fee is equal to gain minus performance fee minus strategy's fee. If total fee is greater than 0, we're going to skip. And if total fee is greater than 0, then reward is going to be equal to issue shares for amount self total fee. It's going to issue an X amount of shares to this own vault for the total, based on the total fee, basically. That's the amount that is going to be, and the reward is just the amount of shares that is issued. So the amount of shares that are issued is stored in the reward variable, given the total fee, and it's then sent to the vault itself. If the strategy's fee is greater than 0, which means that we're going to skip it if it's not 0, then we're going to just give them a reward by doing, again, strategy's fee times reward divided by total fee. And it's going to transfer them to the strategy's reward. It's going to call this transfer function to transfer, I'm guessing, to the strategist, or to the strategy reward, I guess, or the strategy contract. And lastly, if self-balance is greater than 0, if we still have something, then transfer that from self.rewards. Yeah, transfer it to the self.rewards and transfer the amount that is specified by the balance of this account. So basically, it's just going to send everything that is left after calling assess fees will be sent to the rewards the rewards contract. So in conclusion, we have the sweep. Sweep removes tokens from this vault that are not the type of token managed by this vault. This may be used in case of accidentally sending the wrong kind of token to this vault. Tokens will be sent to governance. This will fail if an attempt is made to sweep the tokens that this vault manages. This may only be called by governance. So yeah, this is just a function to withdraw any token that is not managed by the vault or managed by the strategies. We assert that the message to sender is equal to the governance. We assert that the token is different from the token that the vault is using. We check that the value is, if the value is equal to max, then the value will be equal to the balance. And then we just do a safe transfer and we send the tokens to the governance. So this idea of the sweep, which I like to rename it and call it the rug, obviously it's ironic, but fundamentally the sweep function is coded in a way where even a malicious attacker can only send the money to the governance. The governance can only call this function, and the governance can only send the funds to itself. So it makes it very safe, or very deliberate at least, because the only person or the only contract that can call this is the governance, and it can only send them to themselves. I think we covered the vaults. Fundamentally, the big thing is the math related to issuing shares and calculating profits. Let me see if there's unit tests for all of this stuff. Registry, wrapper, strategy, vault, test the config, test losses. Let's just check a couple of these. I really want to check the shares for the test for shares. Define vault, government token vault, vault.gov.deploy, vault.initialize, set deposit. So these are just setting that, setting up the contracts. Test deposit with 0 funds, approve reverts. Okay, this is checking that it reverts if you try depositing from rando. Test deposit with wrong amount. Test. Let me see the issuance of shares. I'm guessing you just do a deposit. We've brought in a reverse balance. Okay. All right. So we see set guest invited from gov, deposit balance, vault.deposit balance, token.balance, vault.balance rando equals to balance. So this is testing that when you make your first deposit, you're going to get amount shares. This is fine. Test deposit all and withdraw all from gov. Vault deposit token balance is balance, vault.balance is balance, withdraw token balance is 0, token balance is balance. Deposit limit, delegated deposit withdraw, delegate deposit withdraw. Transfer from, do not issue 0 shares. Emergency test transfer. Withdraw from B2. This may be the one that we're looking for. Test delegated deposit withdrawals. We have 5 accounts, original token amounts, no returns. Token.approve, with deposit in the vault from A. We assert that the balance of A is 0. We assert that the vault balance is 0. This doesn't have any shares. And then we see that B has been issued vault, but that's because they're depositing on behalf of B. Yeah, we're sending the shares to B. The withdraw from B to C, B, vault withdraw, vault balance of B, C from B. So B is going to call the function to withdraw and send to C. We check the B has nothing and C has the token amount. Approve deposit, C no longer. Yeah, it basically just continues doing this tour of stuff. Let's see with withdrawal, I guess. Okay, test multiple withdrawal. We initialize, we approve, we deposit 1 million. We 1 million way, so whatever that is. We strategy gov deploy strategies for in range. We add a strategy with no harvesting limit, no fee, and 10% of all tokens in vault. Then we have see all the strategies with debt. C.harvest from Gov for S in strategy. It asserts that the token balance of vault is the starting balance if 50% is in the strategies. And for S in strategy, for each strategy, it asserts that the estimated total assets is equal to the balance of S, starting balance. They're all the same. That withdraw only from vault. Vault to withdraw, balance of assert token.balance vault is 0. It calls the withdrawal function with the balance of Gov from Gov. It asserts that the vault is empty and that the total assets, the balance of S and starting balance are all the same, and that withdrawing all the debt, vault to withdraw, vault to balance Gov from Gov, assert vault.total debt is 0 for S in strategy S estimate. At this point, I'm searching to see if there's any calculation on the ratio for the just a calculation of the ratio for issuing shares. That's what I'm really looking for. Blah, 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 share value. Let's see, maybe it's here. No. No. I'll check probably offline if I can find any specific test on that. Up next, I'm going to read over and comment on the strategies code, and which is the thing that is more pertinent for strategists is to check the base strategy. And then there's literally a brownie mix here, brownie strategy mix that you can use to write your own strategies. But that said, I'm just going to go over the strategy real quick, and I'll try and see if there's anything really interesting we can learn from. And perhaps I can do a second follow-up video on this if you're interested. So if you're interested, let me know in the comments. I'm going to check. Basically, we have the same strategy parameters we already saw. This is the interface for the vault. We went through that fairly heavily. Credit available, how much we can borrow. Basically, the debt outstanding is how much the vault would like to pull back from the strategy because it wants to pay back. Expected return. This is based on the previous returns and the difference between time. And then we have a report, the act of reporting the gains and losses. And then we have a bunch of governance stuff. Then we have the strategy API. Each strategy will have a name, a vault. We said that it's associated with one vault, a want, which is the token of the vault, API version, a keeper. We'll check that later, but a keeper is something that automates processes, is active. You need to have an active strategy in order for it to be used. Delegated assets, I'm not sure what it is. We'll see. Estimated total assets is, we'll see again. Tend trigger, tend, harvest trigger, harvest. So these are our 4 keywords that we really want to check, and then everything else is kind of ecosystem that we want to just look at. The base strategy is we're going to be using safe math, safe ERC, nothing crazy here. Let's see, delegated assets is the amount in want of the total assets managed by the strategy and should not count toward Yearn's TVL calculation, total value locked calculation. So the delegated assets is the amount of assets that the strategy is managing, and it's not part of the Yearn's TVL. You can override this field to set it to a non-zero value if some of the assets of this strategy is somewhat delegated inside other parts of Yearn's ecosystem, e.g. another vault. Now, this value must be strictly less than or equal to the amount provided by estimated total assets below, as the TVL calc will be total assets minus delegated assets. Also note that this value is used to determine the total assets under management by this strategy for the purpose of computing the management fee in vault. The amount of assets the strategy manages
It should not be included in Yearn's total value locked calculation across its ecosystem. Okay. We have vault strategy, rewards keeper, the events for harvesting, updating strategy, updating keeper, etc. Minimum report delay, the distance in blocks or seconds, I guess. Minimum number of seconds between report, maximum amount of time, maximum number of seconds between harvest calls. Okay, and that means that each harvest is associated with a report as well. So at this point, we're starting to realize that harvest is the act of reaping the rewards, I'm guessing. So that, which corresponds also to the act of reporting the gains and losses and paying the debt back. So that makes more sense in the full ecosystem now. Then we have the profit factor. Minimum multiples that call cost must be above the credit profit to be justifiable. See set profit factor for more details. The minimum multiple that call cost must be above. Yeah, I'm guessing. Yeah, this is just a way to avoid throwing away gas for no reason. This is to adjust the threshold at which running a debt causes service triggers. See debt threshold for more details. And then we have emergency exit. Only authorized, only strategy. These are just basic modifiers. Only keeper, and you can see the only keeper actually allows everybody and the keeper to do it. So the strategy, the governance, the guardian, and the management, and the keeper can do the only keeper stuff. And that is probably just a fallback to ensure that chores can be executed by as many people as we can afford. Then we have the initialize function, which is an internal function. There's this vault strategies, rewards, and keeper. It just sets all of these values up and it approves the vault for the maximum amounts of rewards. Next, we see use to change strategies. Actually, vault.approve rewards uint means that the vault, we're calling the approve function on the vault and giving the approval of the rewards address for the maximum amount. So that means that whatever these, it's my AirPods die. Whatever these, let me check that the audio is fine. Speaker, yeah, so the audio should be fine. So basically, basically we're saying that whatever this strategy will accrue, it will allow the rewards to be sent there because this strategy will earn shares. We saw that in the shares math. The strategy will earn shares and it will be able to send them to the rewards contract, which can then be used for whatever purpose. Then we'll set strategies, set keepers, set rewards, and you can see they're only high level. Then you have set minimum report delay, max report, profit factor, debt threshold, where the debt threshold by default is 0, meaning any loss will cause a harvest, which will subsequently report the loss to the vault. This may only be called by governance strategy. This will set how far the strategy can go into loss without a harvest. So the debt threshold is basically the amount of debt that the strategy can tolerate without closing in on those losses. That's good to know. And then we see the metadata URI, just to change metadata, is to store the URI of the file describing the strategy. So that's actually really cool. Each strategy will have a metadata URI. So maybe there's literally a graph that shows each strategy. That's actually really cool. Governance, if to want is provides an accurate conversion from AM in way, denominator in way, to want. It basically gives you the conversion rate, estimated total assets. This will provide an accurate estimate for the total amount of assets, principal per return, that this strategy is currently managing, denominated in terms of want. This total should not be realizable, e.g. the total value that could actually be obtained from the strategy if it were to divest in their position based on the current. The total should be realizable. So the estimated total assets needs to be realizable, which means that it has to be, I guess, conservative compared to other estimates that you may use. Care must be taken using this function since it relies on external systems, which could be manipulated by the attacker to give an inflated or reduced value produced by this function based on current chain conditions. It is up to governance to use this function to correctly order the strategy relative to its peers in the withdrawal queue to minimize losses for the vault based on sudden withdrawals. This value should be higher than the total debt of the strategy and higher than its expected value to be safe. So yeah, the total assets needs to be greater than the total debt, but at the same time, this value can be manipulatable. So basically you need to have, it needs to be taken with very attention. We have is active, and we actually see that active is checking on the debt ratio being greater than 0. So that goes back to setting the strategies to inactive was literally setting the debt ratio to 0. So that makes sense. And then we see the prepare return function, which will perform any strategy unwinding or other calls necessary to capture the free return the strategy has generated since the last time its core position were adjusted. So I'm assuming prepare return in the example that I started with my naive example will literally be the act of divesting everything from Aave. Because when you divest everything, you are realizing the returns, all the interest from borrowing and depositing, and then you will also call a function to withdraw your rewards as well. And let's see, this call shall be used in normal operations. And then this method returns any realized profits and realized losses incurred and shall return the total amount of profit losses debt, payments in one tokens for the vault accounting. Okay, so I think we covered this, but basically debt payment should be less than or equal to debt outstanding. Yeah, I'm assuming this will literally unwind the entire strategy and make it basically liquid so that you can use as many funds that the strategy can have. Then we see adjust position performs any adjustment to the core position of the strategy given what change the vault made in the investable capital available to the strategy. Note that all free capital in the strategy after the report was made is available for reinvestment. Also note that this number could be 0 and you should handle the scenario accordingly. So adjust position and you have all the free capital in the strategy after the report, because I'm guessing the report is called here with prepare returns, or it may be called in harvest, but basically you have a bunch of stuff that is liquid now. And so you need to have a function that given the liquid will take that liquid token and use it for something. So let's continue. Liquidate position, liquidate up to amount needed or want of the strategy position, regardless of slippage. Any excess will be reinvested with adjust position. This function should return the amount of one tokens made available by the liquidation. If there is a difference between them, loss indicates whether the difference is due to realized loss or if there is some other situation at play, as you locked funds, or the amount made available is less than what is needed. This function is used during emergency exit instead of prepare return to liquidate all of the strategy. So this would be the liquidated version of the function where it just doesn't care about the realized loss. It just will take a loss just to liquidate. Then we see the tend trigger, which provides a signal to the keeper that tend should be called. The keeper will provide the estimated gas cost that they will pay to call tend, and this function should use that estimate to make a determination if calling it is worth it for the keeper. This is not the only consideration into issuing this trigger. For example, if the position will be negatively affected if tend is not called shortly, then this can return true even if the keeper may be at a loss. Keepers are always reimbursed by Yearn. Okay, so this basically tells the keeper whether they should work or not. Then we have tend, which adjusts the strategy position. The purpose of tending isn't to realize gains, but to maximize yield by reinvesting any returns. So if you have like a way to get your rewards, you will literally get your rewards and then you will reinvest them. And then tending may actually be also the act of also using the investment to generate even more yield. So that's that. Now we see, so tend is one of the most important functions. Then we have the harvest trigger, which provides a signal to the keeper that harvest should be called. The keeper will provide the estimated gas cost, blah, blah, blah. This will call if it's worth it. And then this call and tend trigger should never return true at the same time. See min max report delay profit factor threshold to adjust the strategy's control parameters that will influence whether this call return true or not. These parameters will be used in conjunction with the parameters reported to the vault to determine if calling harvest is merited. It is expected that an external system will check harvest trigger, and this could be a script to run off of desktop. Yeah, basically it's the Python script. And let's see. So we have harvest trigger, call cost. It calculates the cost in way. Then it will check the strategy, gets the strategy params. If it's not active, it's not going to do anything. Should not trigger if it's minimum than the last report. It should trigger if it hasn't been called in a while. So it requires that the last report is greater than or equal to the max report delay. And in this case, it will return true. Then if some amount is owed, it's going to pay it back. Since debt is based on deposit, it makes sense to guard against large changes to the value from triggering harvest directly for user behavior. This should ensure reasonable resistance to manipulation from user-initiated withdrawal as the outstanding debt fluctuates. So what it's saying is that if outstanding, which is the debt outstanding, is greater than the debt threshold, then you will return true. Then we're seeing that if the total assets total is, we add the total plus debt threshold. And if that is less than the total debt, then it will also return true. So if we have a loss to report, we're going to do that. And it's if we have total plus threshold is less than the total debt. So the total debt is higher than the total plus the debt threshold, then we return true. If profit, let's see, total params, the total debt, if total is greater than the total debt, then profit is equal to the total minus the total debt. And that means we earn the profit. And so I'm guessing, yeah, we'll check here. Otherwise, blah, 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 blah. Credit will be equal to the credit available from the vault. And so we're going to check if profit factor dot call cost is less than credit dot add profit. Then we're gonna basically we're gonna check these two. We're gonna multiply the cost of making the call with the profit factor, and we're gonna check if that's less than the credit plus the profit. And then we have the harvest function. So harvest the strategy, recognizing any profits or losses and adjusting the strategy position. In the rare case the strategy is an emergency, this will exit the strategy positions. Let's see, only a keeper can call it, which means that only trusted individuals can. We have the debt outstanding equals to vault.debt outstanding. Then where everything else is 0. If we're in emergency, we're going to basically liquidate everything with liquidate positions. Otherwise, we're going to prepare return, which is the function we already checked, which basically will set itself up to convert those hypothetical gains and losses into actual gains and losses. And that's why we have profit, loss, and debt payment. And we have debt outstanding, which will be reported for the report function of the vault. We checked that already. And basically the vault will tell us what we need to repay. And then we have adjust position, which will show us the debt that is outstanding. So if there's any other amount of funds that we can use, we're gonna use them in adjust position, which, as we said above, can be set to 0. So it can be also doing nothing, I guess. We have withdraw amount needed. It will check by liquidating. So withdraw will literally just liquidate position and then do a safe transfer. So withdraw, calling withdraw, and in fact, it requires that it's called by default, because calling withdraw is basically an act of brute force, because it will liquidate position to get that money, even ignoring the slippage. So if I'm not mistaken, we saw that the vault has a slippage protection in it, and that makes sense that you don't need to have a slippage here, because again, you're forcing it to be called by the vault. We have prepare migration, which was the way to migrate funds. We have the act of migrating, which changes the addresses, and it should also do the safe transfer. Yeah, you just send the entire funds here. And prepare migration should basically remove all of the funds from that and just make them liquid so we can send them around. We have set emergency exit. Once activated, the strategy will exit its position upon the next harvest. And so it's basically going to liquidate everything. And then we have a list of protected tokens. Override this to add all tokenized position this contract manages on a persistent basis. Do not include want, which is already included in sweep below. Then we have sweep, removes tokens from the strategy that are not of type of tokens, and basically it's just a way to withdraw, and it just checks if you are trying to sweep a protected token, because the strategy may have a bunch of tokens that are not the want. So it could be, for example, a Aave governance token or compound governance token, and it will protect them, so they can't be just rug pulled even if they try. Beside that, we have the interface. So I think we covered what a vault does. We covered the strategies. I think the biggest thing is really the math of calculating shares. That has to be the biggest thing, and then the rest of the stuff is just lingo for the specifics of how yield farming works with the harvest and the tend function, which some people may call them something like harvest. I think harvest makes sense, and then you would have rebalance or something like that. So hopefully that was informational. Let me know what you think, and let me know if there's any protocol you want me to cover specifically. I think I'll do Uniswap v3 next. I think there's a lot to be learned there. And yeah, let me know what you think about this format, and have an amazing day. I'll talk to you soon.